Alright, so far we've got our Space Invaders game. We have our game object class created that allows us to kind of move our objects around. We need to add in the move horizontally still, or we need to expand that function still, but we've got our move vertically function that's designed to keep it from going off the screen. And so we're going to run it real quick and we'll see that we still haven't quite solved the problem yet. So we have our alien moving down, but then you see when it gets to the bottom, it goes off the edge and then it stops. We want it to stop when it gets to the edge. And so if we come back to our game object, you can see that we're checking to see if it's equal to, if it's at the last pixel, and we need to add an offset here that's equal to the height of our object. Okay, and so if it's equal to the screen height, and then we're going to say minus height. Like that. And then we'll also say this. Okay, and now let's try that out, and we'll see what happens. Nope, didn't like that. Screen, let's see. We introduce an error here. Okay, that wasn't very helpful. Okay, we're missing the closing parentheses here now. And that should fix it. And now we'll watch it go down. Here we go. It's going down. Hopefully it stops when it gets to the bottom. And nope. Not quite. Oh, here we go. Just add the minus height right there. Okay, that solves our problem. Okay, so the next thing we're going to do is we're going to implement our move horizontally function. All right, and so now we see it coming down. It should stop right there. Okay. So come back to here. So I made a change to this. I'm going to modify it here as well. All right, to account for that. Okay, and now we're going to adjust this to be a move horizontally function as well. Copy that over. So we want it to be the x speed and the new x position. Let me just comment this out for now. So x, 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 and then where we have height, we're going to change that to width. And this should be screen width. Okay, so change that here and here. Change this to be the width here and here. And I think that looks pretty good. Okay. And so now, if we run that, and I'll copy this over. Alright, in our simulator here, we're going to run that. And now you'll see the spaceship will stop when it gets to the edge. So the spaceship going over should stop right there at the edge. Perfect. Alien stop when it gets to the bottom. Okay. And so now that's done, and now we can start to really build our game. Okay. And so let's do that. Let me actually go back to the. Here we go. Okay. So coming back to main. So we don't want just an alien. We want a bunch of aliens, right? And so we're going to make a an array of game objects. So we'll call it the alien fleet, and this will be, we want 2 rows, right? So we're going to be 2 rows of I wonder how many we want. Well, this is some number we can tweak. Okay. What we'll do is we're going to say num alien rows. We'll make that to be 2. Num alien columns, and that will be, let's see, the width of our alien is 12. The width of our display is 128. So we could do maybe like 11. Let's do 10. Let's do 10 aliens wide. Okay. And so now we're going to go like this, rows and columns. Okay. And so now this is an array of alien ships. So we're going to call it our alien fleet. And so we're going to initialize, I will leave this here so we don't get errors on it. We're going to initialize our fleet here. So for int I, we'll actually use x equals 0. X is less than, actually we'll say y. Y is less than the num alien rows, y plus plus, and then we're going to say for int x equals 0, x is less than num alien columns, x plus plus. Okay, and so now we're going to initialize our alien fleet. So alien, so we're going to say alien fleet y x equals game objects, and we're going to maybe get some errors here, so we'll figure this out as we go. We're just going to copy that in. Okay. And that's going to draw them all on top of each other, so it doesn't like this. 2 overloads. So we don't have, so this might come down to an issue with our constructor. So let me take a break here and figure this out, and then we'll come back. Okay, so coming back to this, we're getting an error here when we try to do this, and if we look at these issues, there's a couple things. So basically, the way that we're doing this is we're making a copy of this, and we're saving it to here. There's a couple ways we can go around it. It's giving us an error, though, specifically because when we make this game object, we have to initialize the display, and there's some kind of issue here where it doesn't like us making a copy of the display object here, or at least the reference to it. So I think if we make this to be a pointer instead, which is more like the C way of doing it, and then when we go to draw, so we'll take the pointer, and that should work. And then if we go to draw, instead of the dot here, we put an arrow, and that should make it work. It says we're still getting an error here. Okay, so I think we're okay there now. And so now when we initialize it, we have to put the ampersand here. And so let's see, I tried to do something there that didn't work. And then, so we put that right here, the ampersand there, and right there. So let's see if that works. Not quite. So now we're here. Okay, so we don't have an empty, basically we're creating an empty game object here and it doesn't like that. And so now we need to make basically like an empty constructor, so we can initialize an empty object. And so what we're going to do here is this. We're going to set these default values just to be 0, 0. We'll set this to be null. 0, 0, and null. Okay, and so now let's see if it works. And we're still getting in issues. It says it didn't like that still. Let's see. Oh, okay. This is it. We gotta empty out that. So now we have a constructor here and a constructor here. So this is where we pass in all these objects. This is where we don't pass in anything, and it just initializes everything to nothing. And that should work for us. Okay. And so now, well, let's come back to here. So when we make our alien fleet, this represents the X position, right? This will be X. No, yeah, so this would be X times, so it's 128 pixels. We're going to put in 10 objects. So 128 divided by 10 is 12.8. So let's make them each be 10. Actually 12 plus 4, right? So that would be, yeah, let's do that. So for each one, we're going to move over 12. We're going to have it offset by 4. And move over 10 pixels plus 2 for a space in between them. And then this is going to be 10 times y plus, we'll say 12 times y plus 10. So we'll try rendering this and we'll see what it looks like. Okay, so those are our alien ships that we've basically created our array of alien ships here, and now we have initialized their positions at those positions, and now we're going to try to draw them. We also made some updates here, right? We created this kind of empty game object and we set our display to null. We still don't know this is going to work because we haven't tested it yet, but let's make it so we can draw our alien fleet. So we're going to say make a function here called draw alien. What is all that stuff? Yeah, draw alien fleet. Okay, so we're going to make this function. We're going to up here put a prototype for it. So void draw alien fleet, and then down here we're going to define this function. And we're going to copy in this. Okay, and then here what we're going to do is call the dot draw function. Okay, and if we've done everything correctly, this should, doesn't like that. Why doesn't it like that? What did we call it? Oh, gotta set the color. White. Okay. And so now we can run this in the simulator. Okay, so we run this in the simulator, and now you can see it draws our fleet of aliens. So we might want to put the starting point at like 2 here. They're kind of close together, so maybe we should change this to be 9 of them instead of 10. Nope, right here. So the number of columns, let's set that to be 9. And so then when we do this, let's see, 128 divided by 9 is going to give us about 14 pixels for each. So 9 times 14 is 126. That gives us 1 on each side, so we're going to say plus 1, and then change that to be 14. And we'll see if that's a little better. Okay, that's pretty good, but then also we don't necessarily want them to fill up the whole screen, right? Because they got to dance side to side. So then we're going to go make it be 8. And then we'll do the same thing. And there you go. So now they can move to the side, drop down, go back and forth. And that's pretty good. So now we have our fleet of aliens drawn. Okay, and so the next step will be to make them kind of dance their way down the screen. All right, so coming back to here, we're going to make those aliens dance their way down the screen. So we're going to say move alien fleet. Okay. And we're going to add ourselves a function prototype up here. So move our alien fleet, and then we're going to define our function right here. And this is where we're going to take advantage of these move functions that we wrote. And so we're going to start by moving it horizontally. Move horizontally. And then we're going to say static bool at edge. At edge, we'll call it. Okay. We're going to call that false. And this is basically a variable that's going to stay with this function, and that's what the static does. It means that we're going to initialize it once, and every time we call that function, we can reference the same variable. And then what we're going to do is we're going to also have a direction. So static bool, not a bool, we had direction, right? Oh, you know what? Static uint 8. Static int, we'll just call it direction equals move right. Okay. And so now we're going to move horizontally in that direction. And then we're going to say bool hit wall. And so we're going to say if we hit a wall, we're going to set at edge to be true. Okay. And then we're going to say if at edge. So before we move it, we're going to check to see if we're at the edge. And if we are, we're going to change the direction equals, so direction equals, and we're going to say, I'm trying to think of it. So we have made these so they're opposite, so we're just going to multiply by -1 equals -1 times direction. Okay, so it switches the other way. And then we're going to move vertically here to put it down 1 row. Move vertically, and the direction will be move down. Okay, and then if we hit the wall there, static bool at bottom equals false. Okay, and if we get to the bottom there, then the game's over, right? And so we'll have to handle that later. So at the at bottom, and then at edge, if at edge, we're going to set this back to false now, since we're no longer at the edge, or at least the same edge, because we're moving the other way. So what happens is we come in here. If we're at an edge, we're going to set at edge to false and change our direction, and we're going to move down a row, and then we're going to come back to here. So whether we're at the edge or not, we're going to move over kind of one move, and so this will kind of dance those aliens down to the bottom. And so now we'll test it here in our simulation, and we'll see if it works. Takes a while to compile here sometimes. Oh, and there they go. They're dancing pretty fast, so we might need to slow her down. Slow down. Oh, and that's interesting too. Did you see that? Oh, because we don't handle the at bottom case. That's why they all end up. So that's something we'll have to work on, but that'll be the next video. So, or the next lesson here. So, one thing we can do though is this. We should slow down, or we can set their speeds, right? And so, when we initialize this, we're gonna say alien fleet dot set x speed. We'll set this to be 2 for now, and then we can do alien fleet dot set y speed to be 1. Okay, and so we'll see how that goes. That should probably make it go a little slower. Oh, didn't like that. Oh, that's what it is. We have to index our array there. And so this is initializing all those objects. And there they go, they're going a little slower. We probably want to slow that down even further, so maybe set the x speed to 1. And then even then we might want to slow it down some more. But we can do that when we start working on our game loop here. Well, that's pretty good for that. Okay, so we got them dancing their way down the screen. So next we gotta move our spaceship around, and we gotta shoot little lasers at them. And then from there we'll handle those like collisions, and then we can work on some of the timing issues.